This is a custom circuit board that I'm calling the Envision board, mostly because I'm using it to replace all of the electronics that run the animatronic eye mechanism I designed. Basically, it unites an Arduino Nano and Adafruit servo driver into one compact package so that it can be run off of one cord. In full disclosure, I am no electronics expert. This is my first go at ever making a custom circuit board, but it honestly wasn't as hard or complicated as I thought it might have been. I did it all in an open source program called KiCad, or KiCad, I'm not sure how you pronounce it, and then ordered the parts from JLC PCB. It was incredibly affordable. I think for $2 a board, I had them here within like 3 to 5 business days. So I would highly recommend using their services in the future. And then it's just a matter of putting this together. So with the circuit board in hand, an Arduino Nano will slide into the top slot, and a Adafruit servo driver will slide into the bottom. Let's do the Nano first. So that will go onto the top, and notice it does have a preferred orientation. The USB port needs to be pointing away from the DC barrel jack connector. Notice I did leave an extra row of sockets for each of the pins on the Nano. That'll let you add any ins and outs as needed. And then it's a matter of flipping around to the back and sliding the servo driver into place. And if you notice, there's a switch in the bottom left corner of the board there. That is a mode selector switch that allows you to switch between run mode and program mode. Flip that into program mode when you plug in your computer, and it will protect you from pulling too much current. It basically just turns off the motors but keeps everything else powered on. So that's it. That's the Envision board. I basically did this project as an excuse to force myself to learn PCB design, but all it requires is a power supply that can handle the number of servos you're using. In this case, I'm only using 8, so a 3 amp power supply is more than enough for me. You plug it into the DC barrel jack connector, see that everything lights up, and then you're good to go. In the meantime, I've been playing with even smaller and more compact microcontrollers and hope to be updating this more in the future. But for now, that's all from me. Let me know, as always, if you have any questions. Bye-bye.